This is Saxon Advanced Math, lesson 61.8. This is single variable analysis. Now we need to come up with a couple of terms right off the bat here. And some of this is going to be a review for you. Other parts of this will be new, but most of this is just taking some terminology we already knew and applying that into a little bit different thinking method than what we may have in the past. So the first thing I want to talk about is average. And we know what average is. It's a central tendency. It allows us to tell where the average of the numbers are, the middle of the numbers as far as it goes. And we already know what that is. It's the sum divided by the count. And we don't think of it that way in our heads. We think of, well, average. It's so easy. You add them up, divide by how many there are. Well, that's the sum divided by the count. And we're going to use the Greek letter mu for that. Standard deviation is a little bit different. Standard deviation is talking about how far something is from the average in comparison to all the other numbers distance from the average. Now that sounds a little bit hard, but let's go ahead and break that down. And this is a little more in depth than what the book is showing you at this point, but I think it's important for you to understand where these numbers are coming from. If I took the numbers 80, 81, 79, and 80, and I looked at those are all really close together. If I found the average or the mean or the mu of that, I would just say 80 plus 81 plus 79 plus 80 is 320 divided by 4, that's 80. Well, there we go, it's an average of 80, and we can see that. But if I looked at these set of numbers, 10, 30, 160, 120, these are really spread out. But if I add them up, I still get 320, and divided by 4, I still get 80. So looking at the average of numbers being 80 doesn't really tell us how spread out the numbers are. It only tells us what the average of those numbers are. Well, we need a better way to describe number sets, and so the standard deviation allows us to show how far apart the average number is from the average. Well, that would make sense. So let's take a look at this. If I said this, we'll look at this and we'll see why that works. If I looked at 4, 7, 9, and 20, I'd say the average of those is 10. And I didn't do the numbers in the middle. I think you guys can handle that, just averaging those numbers. If I put them on a number line, like 0, 5, 10, 15, 20, and I graphed them, I looked at it, and I can see this on a number line with just the 4 numbers, that I've got more numbers spread over here than over here, and 20 is kind of all the way out. The range of these numbers, that's another term we know, 20 minus 4 is 16. But the deviation is going to be a little different. If I took how far away those deviate from the mean, I would say, well, 9 is only 1 away, right? And 7 is 3 away. So if I took each one of those numbers and said, like, for instance, here's our first number, 4 minus 10, that's our average, I'm going to get negative 6. That's the deviation from the mean. That's another new term for us. It's how far it deviates from the original. Where's the original? The mean. So the mean is 10. How far is 4 deviating? Well, negative 6. It's directed, left 6. So 7 minus 10 is 3. 7 was our second data point minus our average 10. And I get a negative 3, and I realize that's directed to the left 3. And then I look at the 9 and say, well, that's directed to the left 1. And 20, which is directed to the right 10. Once again, if I just took all these numbers and I added them up, the problem is the average of the deviations, is going to be 0. Negative 3, negative 6, negative 1, and 10, well, that's 0. So we can't just find an average of the deviations. We've got to be a little more unique than that, because an average of a deviation will always end up being 0. And that doesn't tell us anything, so we didn't gain anything with that. So we're going to, instead of talking about the deviation from the mean, let's put more weight on things that are further away and less weight on things that are closer together. Well, how would I do that? Well, if I square something, things that are further away, twice as far away becomes actually 4 times the importance, right? 2 squared, 4, instead of just twice as far. 3 times away becomes 9 times as important. So we are going to take and adjust that to be how far away those are by taking each one of our deviations, our directed deviation, and we're going to find a variance. A variance is the average of the squares of the deviation. Well, and the reason why that's so important, all of a sudden we don't care if it's to the left or to the right. We want to know how far it's spread. So we're going to square that. That's going to take care of our negatives. So a negative 6, right, there's our first value, squared. a -3 squared, a -1 squared, a 10 squared. And once again, we're going to average the sum of the squares. So how do I average? Average the squares. I'm going to sum them, plus, 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 right? And I'm going to divide by 4, because there's 4 of them. That's going to give me a variance of 36.5. Well, the variance is important, but it doesn't tell me anything yet. It's really not a good number that I can use. But if we took the square root of the variance, and the reason why is because we squared each one of these and added them up, we take the root of this number, that's going to get us 6.04. That's what standard deviation is, and we're going to call that sigma. So a standard deviation is simply taking our mean, how far apart each one are from the mean, squaring them, adding them, dividing by how many of those are. So I'm averaging the sum of squares. Okay, well that makes sense. So 36.4, and then I find the root of it to find what the standard deviation is. Look at 61.1 in your books, and I rewrote their problem to make it a little more palatable for us, but it's find the mean and the standard deviation. They gave us this list, 12, 7, 15, and 10. First thing I always do with a list like this is I put it in numerical order. I like to work with it in numerical order. It makes sense in my head. 7, 10, 12, 15. Well, if I wanted to find the average of these, I would say, well, average, once again, is what? Sum divided by count. So I say sum, 7 plus 10 plus 15, or plus 12 plus 15, divided by 4, and that gives me 44. Divided by 4 is 11. 11 is my mean. Well, once again, how do I find out my deviation? Well, my deviation will be 7 minus 11, which is -4, 10 minus 11, -1, 12 minus 11, 1, 15 minus 11, 4. Now, once again, if I added all these up, I'd end up with 0. It's a good way to check it, but I'm not going to add those. I'm going to take the square of each one of these and add them. Okay? So the ones that are further apart become more weighted. The ones that are closer have less weight, and I'm going to say -4 squared plus -1 squared plus 1 squared plus 4 squared, and that's going, I'm going to add them all up, divide by 4, take the square root, so I'm doing all this in one step, and I get a standard deviation of 2.92 and a mean of 11, and there's the answers for 61.1. And it really is that simple. Don't let the big words scare you. All we have to know are these couple of new terms, okay? If you've never used mu for mean, that's fine. That's the average. You also had to know standard deviation. That's over here. We have to also know what range is. Range is not new, but we've not used it in a while. It's the largest number minus the smallest number. You have to know what deviation is. Deviation, how much do I deviate from where I was supposed to be? Well, how much, and it has a direction. Deviation has a direction. Standard deviation does not have a direction. Okay, but deviation does. So it's a directed difference. It's going to have negatives going to the left, positives going to the right, just like a number line. If I square those, add them up, divide by how many there are, which is like averaging the squares, okay, then I end up with 36.5 on this one. That is the variance. So that's another new term. Variance is 36.5. But then I need to take the root of the variance, and that root of variance is going to tell me the standard deviation, which is abbreviated as sigma. So the standard deviation is 6.04. It's pretty self-explanatory on a lot of this stuff. You can play with larger sets of numbers. We did this with a small set with just 4 numbers on each one of the examples. You could do this with 20 numbers or 30 numbers. Of course, the math becomes a little more difficult, but you're going to see in the next section how you can do this with a calculator, and it becomes really simple. But for now, we're doing this by hand, and you're just doing some general math, squaring, adding, dividing. It's pretty simple. So we shouldn't struggle with this. Make sure you rewatch this if you need to go over it. Do each one of these steps along with the video if you need to. But you'll catch on with it. It's not a difficult thing. This is looking at numbers and how numbers spread out and how we're able to direct how far away they are or describe how far away they are from the average.